So welcome back to Ella's Academy. So what we want to do now is class interval and class limits. Class interval and class limit. Now a symbol dividing a class such as, look at this, 40 to 42, 43 to 45 is called a class interval. The interval between 14 and 42. So the interval between 14 and 42 is 41. That is 2 2. 41 and 42. So if you look at this, it's 44. So the interval between this and this, is called class interval. So while the odd numbers, we have odd numbers. All these, they are odd numbers. So while the odd numbers, 40 and 42, 43 and 45 are called class limits. They are called what? Class limits. All of them, they are called class limits, but we differentiate them into two. Some are smaller numbers and some are bigger number, that is upper number. So if you look at this number, the smaller number 40 and 43, 40 and 43, the smaller number 40 and 43. Don't be confused that we call this one smaller number, because this is the position of this 40 and 42 is the position of 45. So the smaller number 40 and 43, we call them lower class limits. We call them what? Lower class limits. While 43 and 45, we call them upper class limits. Upper class limits. So let's move to class boundary. If you look at the board, we have the table we use in our introductory part. So this is class interval and this is frequency. Now we want to get our class boundary. Our class boundary. Now, how do we get our class boundary? So to get our class boundary, if you look at this table, we have class interval. So we will get our class boundary from our class interval. So if you see 40 to 42 is our class interval. So, and how do we get our class boundary? To get our class boundary, we deduct 0.5 from 40. We deduct 0.5 from 40, 0.5. That is 40 minus 0.5 to get our lower class boundary. So from here, if you deduct 0.5 from 40, it gives us 9.5. Now, when you deduct 0.5 from the lower class interval, then you add 0.5 to upper class interval. So from here now we have 42. If you add 0.5 to this, it will give us 42.5. Now you subtract 0.5 from 43. If you subtract 0.5, 43 minus 0.5 will give us 42.5. You now add 0.5 to this, it will give us 45.5. Now something happened here. If you look at the upper class limits here, upper class limit, and look at the lower class limit here. So by the time we look for the boundary, what ends here, we start here. What ends here, we start what? We start here. Now we have 45.5. Now let's do the same thing here. We have 46. If you subtract 0.5 from 46, we have 45.5. You add 0.5 to this, 48.5. You subtract 0.5 from this one, we have 48.5. Then 51 plus 0.5 will give us 51.0.5. So 52 minus 0.5 gives us 51.0.5 to 54.5. So that is how we solve, and that is how we get our class boundary. That is how we normally get our class boundary. So what we normally do is that you subtract 0.5. You subtract what? You subtract 0.5 from lower class limits, and you add 0.5 to upper class limits. Now if you look at the board, we have lower class boundary. We have two class boundary. We have this side, we have this side. So these sides we call them lower class boundary, lower class boundaries, and all these sides we call them upper class boundary. We call them upper class boundary, and the whole of this we call them lower class boundary. So now, what is excess of class boundary in our table? If you want to solve for median or mode, that is where we will make use of our class boundary, because the formula for median is L1 plus n over 2 minus CFB all over FM. So we haven't gotten to that place, that point whereby we teach you median or mode. But I'm just telling you the importance of class boundary is to get our lower class boundary when we are calculating for our median or our mode. So another thing I want to tell you is this: when you are solving for something like this in group data, don't forget we got this from this number. What of if the examiner give you something like 40.5 to 42.5? So how do you get your class boundary? That is 42. Okay, let us assume. Let me use only this one to explain. If the examiner gives you something like this, how do you get your class boundary? So to get your class boundary, this one is a decimal number, and this one is what? Whole number. This one is what? Decimal number, and this one is what? Whole number. Now, to get your class boundary here will now be 40.5. Don't forget, to get that one we subtracted 0.5 to get this one. But if the question is given to you in decimal form, that is 40.5, you now subtract 0.05. You subtract what? 0 minus 0, subtract 0.05 from this to get your class boundary. If the number is given to you in a decimal form, don't forget, if the number is given to you in a decimal form, you will subtract 0.05. But if it is given to you in this form, you subtract 0.5. Please don't misquote me. If the number, your group data is in whole number, you subtract 0.05, then you add 0.05. But if it is a decimal number, 42.5, you subtract 0.05, then you add 0.05. Sorry, this one is 0.5. So you add 0.05 to the upper class limit, and you subtract 0.05 from the lower limits. So that is about class interval. That's about class interval. So let's see how we get our class size. So to get our class size will now be differences between two class differences between two upper limits or lower limits. Now what we are saying is this: to get our class size, 45 minus 42. 45 minus 42 will give us what? 3. Now 43 minus 40 will still give us 3. If you subtract 42.5 minus 39.5, it will give us 3. So to get our class size will be difference between the lower and upper class boundaries, or the difference between two upper limits or two class limits. So two upper limits or two class lower limits. So that's how we get our class size. And the class size is called width or strength. Width or strength. So we want to discuss about class marks. We want to discuss about what? Class marks. And what is the class marks? Class marks is, and how do we is the addition of the lower limits and upper limits divided by 2. Addition of lower limit and upper limits divided by 2. That the lower limit is what we normally call our x. Is what we call what? Our x, and it's our midpoint. Our midpoint. Our mid. Let me just call it mid. Our mid. So our mid and our x. So, and how do we get our midpoint? Our midpoint is 40 plus 42 divided by 1. So 40 plus 42 is 82 divided by 1 will give us 41. Then 43 plus 48 will give us 88. 88 divided by 2 will give us 44. So this plus this divided by 2. 46 plus 48. So will give us 94. So 94 divided by 2 will give us 94 divided by 2. That is 47. This will give us 47. Then this one will give us 50. So that's how we get our midpoint. That's how we get our midpoint. So let us move to another subtopic, which is measurement of location for group data. Measurement of location for group data, which is mean, median, and mode. Which is mean, median, and mode. Measure of location for group data. Measure of location for group data. In brackets we have mean, median, mode. Mean, median, mode. Mean for group data can be calculated in 2 ways. Can be calculated what? In 2 ways. The first one is mean without assumed mean. That is, which is normal one, which is summation fx over summation f. Summation fx over what? Summation f. Where our s is the class mark or midpoint. The second one is mean with assumed mean. The examiner will surely give you your assumed mean. Your examiner will surely give you assumed mean. So, which is a plus summation fd over summation f. So where our a is assumed mean, where our d is x minus a. Our d, how to get our d is x minus a. That is deviation from the mean, which is x minus a. That's how we got our d. Now we are going to practice the 2. We are going to practice the 2. We are going to use the same question to answer the 2. How do we use how you can calculate for your mean without assuming, and how you can calculate for your mean with assumed mean. So this is a question. The table below shows the distribution of ages of 22 students. Ages of what? 22 students in the school. Age, we have 12 to 14. 12 to 14 is 6. We have 15 to 17. 15 to 17 is 10. We have 18 to 20. 18 to 20 is 3. 21 to 23 is 2. And 24 to 26 is 1. So, solution. So we have our interval. Age interval, we have 12 to 14. This is our frequency. So we need our midpoint. Our midpoint is our x. Our midpoint is our x. So our frequency of this is 6. Then our we have this from 15 to 17 is 10. Our frequency. Then 18 to 21 is 3. 21. So to get our midpoint will not be 12 plus 14 will give us 26. 26 divided by 2 will give us 13. Then the next one is 15 plus 17, 32. 32 divided by 2 will give us 16. Then 18 plus 20 is 38. 38 divided by 2. 38 divided by 2 will give us 19. Then 21 plus 23. 21 plus 23 is 44. 44 divided by 2 will give us 22. 24 plus 26 is 50. Divided by 2 will give us 25. So let us add our frequency. 6 plus 10 will give us 16. 16 plus 3 will give us 19. 19 plus 2 will give us 21. 21 plus 1 will give us 22. So it must be tallying with this. The frequency must be the same with this. So from here now, we want to solve for our mean. Let's first of all solve for our mean without assumed mean. Without assumed mean will now be equals to summation fx over summation f. So we need summation fx. So that means we need to multiply our f by x. Our f by x. So our f by x now will now be 6 times 13. 6 times 13 will give us 78. So the next one is 10 times 16. 10 times 16 will give us 160. 10 times 16 will give us 160. So the next one will be 19 times 3. 19 times 3. 19 times 3 will give us 57. So the next one will now be 22 times 2 will give us 44. 44, then 25 times 1 will give us 25. Will give us 25. So let us add them together. That's the summation of fx. So by adding everything, what we have is 364. By adding everything together, we have 364. Now to solve for our mean now. To solve for our mean, will now be summation fx. This is our summation fx. Will now be 364 divided by summation f, 22. So if we divide 364 by 22, what we have is 16.5. 16.545. 16.55, sorry. 16.55. So that's how we can solve for our mean without assumed mean. So let's see our mean with assumed mean of 19. So with assumed mean of 19, our mean with assumed mean of 19, with assumed mean of 19, with assumed mean of 19. So we can clean the box up there. So with assumed mean of 19, so by doing that, the formula is A plus summation FD over summation F. So we need D. We need D, and how can we get our D? Is X minus assumed mean. To get our D is what? X minus assumed mean. This is our X minus assumed mean of 19. So now let's start. Our D now, 13 minus 19 will give us minus 6. 16 minus 19, 3. 19 minus 19, 0. 22 minus 19, 3. 25 minus 19, 6. So what they ask us is summation FD. That we need F what? FD. How can we get our FD now? This is our D. Our D is minus 6. Our F is the frequency 6. So minus 6 times 6 will give us minus 36. Minus 3 times 10 will give us minus 30. 0 times 3 will give us 0. 3 times 2 will give us 6. 6 times 1 will give us 6. So now let us add everything together. So by adding everything, minus 36 minus 30 will give us minus 66. Minus 66 plus 12 will give us minus 54. So that's our FD. So from here now, we now have, let us do it up there. Let us do it up there. So our mean with assumed mean will now be A plus summation FD over summation F, which is equals to A. Our A here is what? With assumed mean of 19. Assumed mean of 19, our A is 19. So which is equals to, then our A is what? 19. So summation FD is minus 54, where our summation F is 22. So from here now, we have our mean equals to A, 19 plus summation FD minus 54 over 22. So from here now, our mean will now be 19 plus times minus, we have minus. Then 54 divided by 2, divided by 22, divided by 22. So what we have is 2.45. So now 19 minus 2.45. 19 minus 2.45. So this will give us 16.55. So this is our answer with assumed mean. As you can see, we calculate for it without assumed mean. We got 16.55. So we calculate for it also with assumed mean. We get 16.55. So any which way, you are going to get the same answer. Sometimes during your examination, the examiner will require you require you to solve for your mean using assumed mean. But mind you, they will give you your assumed mean, while some will not even ask you to use assumed mean. Sometimes they give you the two and they now ask you to pick one. That is about mean, how to calculate for mean in group data. So the next one now, let us move to median. So let's calculate for median and mode in another episode. That is another part. So this part now is getting longer, but we are still going to use the same example. Thank you.